Hello and welcome to exercise 1 on page 15 of the workbook. And in this video, we'll actually be working through exercises 1 and 2. They kind of go together. Okay, so let's get started reading exercise 1 here. So they give us two functions, f and g, and they'd like us to calculate some limits and function values. Now there is one issue that I'd like to talk about before we dive into this question. Notice that for both of these functions, they give us a formula and a graph. But the formulas are kind of unusual, and I'm wondering if maybe some of you have seen this notation and others maybe haven't. This type of a function that we see here is called a piecewise function. What's unusual about it is that we've got two different formulas for the function depending on the x value that we're plugging in. Okay, if this is the first time that you've seen this notation for a function, I want to spend a minute just talking about what that means. Okay, where does the graph come from? Okay, well, let's think about how we would plug numbers into this function f, and I'm going to use the space up here above. So let's say that we wanted to plug -2 into the function f. Okay, well, we have to make a decision which of these two formulas we want to use, and the idea is you need to look at the x value that you're plugging in and use that to decide which formula you're going to use. Okay, so -2. Which of these two statements does it make true? Is 2 less than -1, or is it greater than or equal to -1? It's actually less than -1, which means that we'd want to use the formula 2x plus 4. So we're going to take that 2 and plug it in for x in the formula 2x plus 4. If we do the arithmetic, that's going to give us -4 plus 4 is 0. And so f of -2 is 0. Notice that that point is on our graph. It's sitting there. That's -2 and 0. Okay, what if you wanted to plug in the number, let's just say 1. Okay, and I'm going to clear away a little of the clutter that we have here. All right, so we do kind of the same thing. We'd look at the number 1 and we'd ask, which of these two statements is true? Is 1 less than -1, or is it greater than or equal to -1? It's actually greater than or equal to -1, which means we'd want to use the second formula for that value. Okay, so we'd take 1 and we'd plug it into x squared, which would give us 1 squared, and we'd get an output of 1. Okay, so the point on the graph, x is 1 and y is 1, notice that that point is on our graph. Okay, so this graph that you're looking at down here really does come from this function. Okay, it's just a function that's in two pieces. We have to decide which formula we use based on the x value that we're plugging in. Okay, good. So that said, let's see if we can actually answer the question that they asked us. Okay, I'm going to just clear away some stuff here. All right, so let's first jump down to part A. And for each of these questions, we really have our choice whether we want to use the formula or the graph. Probably easiest to use the graph. Okay, so f of -1 is just saying substitute x equals -1 into your function. That would be here. And tell me what the y value is that we get out. Well, the point on our graph is sitting up here at y equals 1, and so it looks like 1 would be our value. Okay, then next we come to the limit as x goes to -1 from the right-hand side. Okay, so that's asking us, how are the y values of our function behaving if we take x values that are a little bit bigger than -1 and approach -1? Okay, where would that be on our graph? Well, let's see. -1 is here. If we take a number that's a little bit bigger than -1, that would put us over here. And we want to slide in the direction of -1, which means we're going to slide to the left and ask, what are the y values approaching? Well, it looks like we're getting closer to that point, which is at y equals 1. Okay, similarly, we take the limit as x approaches -1 from the left. That means we're going to take a number that's a little bit less than -1, find where our function is, and we're going to slide along the function in the direction of -1. This time it's going to take us to the right. And what are the y values approaching now? They appear to be approaching that open circle, which has a y value of 2. Okay, so we're going to get 2 for our limit there. Okay, And that takes care of f. Let's move over to the function g, okay, whose graph is given here. First question is, what is g of 2? Okay, well, here's the number 2, and they're just asking what's the y value that we get if we substitute 2 into our function. Well, we have a point right there whose y value is 1. Okay, and so that's the value of g. Okay, and then we come to the limit as x approaches 2 from the right-hand side of g. So that means we're talking about x values that are a little bigger than 2. So we can maybe choose a number here, find out where our function is. And we are approaching 2, so we want to slide along our graph in the direction of x equals 2. That's going to take us back to the left. And what are the y values approaching as we do that? Well, it looks like we're getting close to that open circle, which has a y value of 3. Okay, so that limit's going to be 3. And finally, let's see, f, we're talking about the limit as x approaches 2 from the other side, from the left-hand side. So now we're talking about x values that are a little bit less than 2, maybe over here. We'll find our function. And if we want to slide along the graph towards 2, this time we need to move to the right. And the y values are approaching that same open circle, which is at 3. So that limit is also 3. Okay, so I think we have completed all the parts that we wanted to for exercise 1. Let's scroll down and see what exercise 2 is asking us. Okay, so part A asks, does the limit as x approaches -1 of f of x from exercise 1 exist? Okay, and this limit, again, is what we're calling a two-sided limit. We've talked about how that will exist if we get the same number as we approach -1 from the right and the left. Do we get the same number? Okay, well, notice if you look back up at our answers to 1, we got 1 as we approach -1 from the right, and we got 2 if we approach it from the left. Those numbers are not the same, which means that this limit does not exist. Okay, the limit from the -1 from the right is not the same number as the limit from the left. Okay, we got 1 from one direction, we got 2 from the other. Okay, what about part B? Does the limit as x approaches 2 of g of x from exercise 1 exist? Okay, well, same idea there. We're just asking if we approach 2 from the right and from the left, do we get the same number? Well, notice that in this case, we got 3 from the right, and we also got 3 from the left. So because those numbers are the same, this limit actually does exist. Okay, because the limit as x approaches 2 from the right and from the left both equal each other. Those both had the value of 3. Okay, and we are done.